Hi everyone, I'm Yushi.
安梦圆
Today we are going to present our final project on recycling material classification. Proper recycling plays an important role in reducing environmental impact and supporting sustainable waste management. However, manual sorting of recyclable materials is often inefficient and prone to human error. To address this challenge, we set out to develop a deep learning-based image classification system that can automatically identify recyclable materials using computer vision techniques. In this project, we implemented and compared three different approaches: a custom CNN built from scratch, a ResNet 18 model using transfer learning, and a combined model that uses features from both ResNet and our custom model. All models are trained to classify five categories: cardboard, glass, metal, paper, and plastic. We refer to three peer-reviewed papers for cadence. The first paper introduced AlexNet, a CNN that achieved top 5 error of 17% on ImageNet. It inspired the architecture of our custom model. The second paper compared multiple CNNs and pre-trained models for recyclable material classification, finding ResNet 50 v2 version achieved the best performance. And the third paper combined ResNet 50 with an SVM classifier and demonstrate the effectiveness of using deep learning for waste classification. So both the studies support our use of transfer learning with pre-trained ResNet models. Now I will pass slide to Mengyuan to introduce the custom CNN.
Like Yushi said before, our customized CNN is inspired by the AlexNet. We utilize larger kernels to capture the structure and then the shape of the image. And then we utilize the small kernels to capture the texture of the image. For the details, you can refer to the image on the left-hand side. During the training procedure, we utilize SGD optimizer, and then we utilize the cross entropy loss function, and then we utilize accuracy metric to um, analyze our performance. Please look at the right-hand side figure. You can see our model fits really well, and then after final epochs, our accuracy reaches 82% on validation dataset. Next slide, please. After that, after training phase, we test our model on over 2,000 unseen test images, and our accuracy reaches over 80%, which indicates strong generalization across datasets. Please look at the right-hand side confusion matrix. You can see that two classes, which is paper and cardboard, are classified with slightly high accuracy, achieving values 0.989 and 0.84 respectively. And the primary confusion occurred in plastic and metal categories. You can see that some of the plastic and metal classes is classified as glass. So to increase this two classes accuracy, we introduced the ResNet 18 to help us with this. And then I will pass to Yushi to introduce us that model.
So after observing that the custom model didn't achieve a very high accuracy, we aim to improve the performance by implementing the transfer learning with a ResNet 18 model. We choose to use the ResNet 18 because it offers a better balance of performance and efficiency for our small dataset training. And we use a version pre-trained on ImageNet, and frees the base layers to preserve blend features and replaces the final fully connected layers with a custom classification head. And the model was trained using SGD optimizer with a learning rate of 0.01 for 10 epochs. And we track the trading and validation loss and accuracy across each epoch, as shown in the graph. And the training loss steadily decreased, while accuracy increased to 92.99%, and the validation accuracy reached to 91.59%. So it demonstrating its strong generalization to unseen data, and it also shows that it achieves a better performance than the custom model. We then evaluate the ResNet 18 model on a separate test dataset. It achieves an average loss of 0.2485 and accuracy of 91.84%. The normalized confusion matrix shows that most classes are predicted with high accuracy, ranging from 0.9 to 0.97. But the mean confusion occurs between the glass and similar look classes like metal and plastic, resulting in the lowest class accuracy of 0.84. This confusion may be due to the visual similarity on the certain lighting or angles, making them harder to distinguish. So to address this problem and further increase the accuracy, we introduced another solution, which is the combined model of ResNet 18 and the custom CNN. I will pass slide to Mengyuan.
Yes, like Yushi said before, this combined model is inspired by the recognition of the importance of material-specific physical characteristics on classify these categories. So for this combined model, we utilize the ResNet model with RGB input and then utilize the custom CNN model with Y channel from the YCBCR color space as input. So, and then we concatenate these features from two models on the final fully connection layers. You can see our accuracy output in the image. The training procedure is pretty much similar to the previous two models, but for this model, we only trained 20 epochs. And then after the final epoch, the accuracy reached over 94% on the validation dataset. Next slide, please. And then after the training process, we test our model on over 2,000 unseen test image as before. The accuracy reaches over 96%, which is really good. And this indicates strong generalization across datasets. And you can see from the right-hand side confusion matrix, all classes were classified with high accuracy with values ranging from 0.94 to 0.99. And then our model well balanced the predictions, which means the prediction output is not biased towards one classes over other classes. Next slide, please. And then is our final comparison between different results. You can see from the table, our combined model reaches higher accuracy on the testing dataset, which is 0.96 accuracy. This also means we successfully classify recyclable materials. And this also conforms the practically of ResNet-based transfer learning for real-world material classification. Furthermore, it also highlights the value of integrating material-specific physical characteristics into deep learning models. What's more, we also integrate the trained combined model into a live stream webcam classifier. And then I will pass it over to Yushi to demonstrate this.
Now let's move on to the demo of our recycling classifier. You can either choose to click this link to access the video or watch the video here. Here is our real-time classification system in action. It uses the funnel-trained combined model to identify recyclable materials directly from webcam input. As the camera captures video frames, each frame is pre-processed and passed to the model. The predicted material type is displayed on the screen along with a confidence score. To make the predictions more reliable, we set a threshold of 75%. If the model confidence is below this value, the item is classified as other, indicating that it may not belong to any of the 5 recycling categories. Now let's try a few examples. Glass, metal, plastic, cardboard, and paper. As we can see that all classes are correctly identified with very high confidence. And users can also press S key to save the current frame with the prediction, and press Q to exit the application. This demo showcases how our model can be applied in a real-world scenario for automated recycling classification. That's all from our demo. That is end of our presentation. Thank you.